Hello everyone, welcome to TIN 205 Industrial Statistics 1 with me, Ferry Afrinaldi, PhD. This is the chapter 1 of Industrial Statistics 1, which is the introduction. So, in chapter 1, I will explain the concept of engineering method and its relation to statistical thinking. And after that, I will explain statistic, population, and sample. So on this video, I will just explain the first two, and I will continue with the third, the fourth, and the last topic in the next video. Now, who is an engineer? An engineer is someone who solves the problem of interest of the society by applying the efficient scientific principles. I think everyone in my class should know what is the scientific principle because it is part of your previous course in the introduction to industrial engineering. Now, how the engineers do this, how the engineers solve the problems of interest to the society. They do that by designing or by refining a new product or a new process that meets customer needs. So it is very clear, I think, when people need a quick way to move from point A to point B, from city A to city B, then the engineers design transportation method. For example, they design motorcycle, they design car, and they design airplanes. So that's how the engineer solve the problem of interest of the society by applying the scientific principle, and they apply the scientific principle to refine or to design a new product or a new process. Now, what is the engineering method or the scientific principle? The engineering method consists of several steps. So it is very clear that at the beginning we have a problem that we want to solve, and that problem is the interest of the society. So the first step of the engineering method is to develop a clear description of the problem. So you need to have a clear statement, what is the problem? For example, we need a quick way to transport material from point A to point B. Sometimes when you are stating a problem, you also need to to make a statement on uh, uh, the scope of the problem, and also on the constraint of the problem, or on the requirement of the problem. For example, we need to transport material from point A to point B, and the time that we need to transport the materials from point A to point B, maximum it should be 1 hour, for example. So that's a restriction to the problem. You cannot transport material from point A to point B longer than 1 hour. It should be less than 1 hour. So that's an example of the requirement or the constraints of the problem. Now, and then after developing a clear description of the problem, we need to identify the important factors of the problem. And then after identifying the critical factors of the problem, we can propose a model, and we're gonna use that model to solve the problem. So a model is a representative of a real case or a real life event. That's a model. So how the engineer identify important factors of the problem and then model the problem? They can conduct experiments. So they can do a test in the lab, not only one, maybe several tests in the lab, and then based on the result of the test, they identify the important factors of the problem, and then they propose a model to that problem. So the model can be a physical model. It, so an example of a physical model is a prototype, and it can also be a mathematical model in the form of an equation, a graph, or a computer program. So that's a model, and that computer program, that formula will explain the characteristic or the behavior of the problem faced by the engineer. And how they get that model, they can one of the way in order to have that model is by conducting experiments. And based on the model, the engineer can do some manipulation, and by doing that manipulation, the engineer can have the solution to that model. And after they have the solution of the to the solution to the problem, then they can make the conclusion and give recommendation to the society. So this is the, the, the steps involved in the engineering method. So this is in general, this is the way followed by the engineer in order to solve a problem. Now, this is an example of a problem in the context of engineering. So it is case one. So we want to design a cold storage warehouse, and there is a specification for the problem. It is the maximum heat transfer through the walls is 300,000 joules per hour per meter square. So this is what I say as the limitation or the constraint of the problem or the requirement to the problem. So what is the requirement for this problem? The maximum heat transfer, the maximum amount of heat flowing inside the wall is 300,000 joules per hour per meter square. And there is other condition, and this requirement should happen when there is a 30 degrees Celsius temperature difference between the inside surface and the outside surface of the insulation or or between the inside part and the outside part of the wall. So when there is a 30 degrees Celsius temperature, the amount of heat that can flow from outside to inside, should not be more than 300,000 joules per hour per meter square. And then what the engineer does in order to solve this problem? They come up with two material. Material number one is the rock wool, and material number two is the foam insulation. Okay, and based on the experiment that he does, so he concluded the conductivity or the conductivity level of those two materials is the important factors to that problem. So it is very important to mention that experiment, it is not the only way to define an important factors. We can also have, or we can also get the important factors to a problem based on our knowledge in physics, in chemistry, in mathematics, and also in other part of science. So, but in this problem, he know that the conductivity level of the materials is one of the important factors to the problem, and there is other factors that he consider is important, which is the cost of the material, the cost of material per meter cubic. So the cost of rock wool is about $12, and the cost of the foam is about $14. And the problem is that what material should be selected? But this problem statement is incomplete. So the problem statement should be what material should be selected such that the requirement of the heat transfer is fulfilled, and we want that solution to give us the minimum amount of cost. So that's the complete problem statement for this problem. Okay, so this is the model that the engineer can use. So in order to get this model, there is no experiment that he need to do. This model is from physics. It is from the the heat transfer branch of physics. So he can use this formula in order to find what is the thickness of the wall, so that the amount of heat flowing from the outside to the inside of the wall is not more than 300,000 joules when there is a 30 degrees Celsius temperature difference between the outside and inside part of the wall. And the two material that he need to consider are the rock wool and foam insulation, and he wants to find a material that fulfill that requirement and give him the lowest amount of cost as possible. So that's the problem. He want to determine the thickness of the wall, and then what is the material of the insulation, so that the amount of heat no more than 300,000 joules when there is a 30 degrees Celsius temperature difference, and the material that he used at that level of thickness should give him the lowest amount of cost. So in order to find the thickness, he can use this model, the model that we know from heat transfer. So I think it is very clear what is the problem of the model, what are the important factors. I already explained it. What model can we propose? We have the model from heat transfer, we have the model from physics. What manipulation on the model that we need to do? From the model we can from the equation we can do a very easy manipulation. So from that manipulation we can determine the value of L, which is the thickness of the wall, and by plugging all the numbers to the model, we can have the solution, and based on the solution the engineer can recommend the thickness and the type of material that should be used. But there is a problem. There is another problem encountered by the engineer from that problem. It is regarding the conductivity level of the material. If we are coming back to the problem, see that. So he performed 10 tests in order to determine the conductivity level of the material. The problem is that what number or what is the level of the conductivity that he need to use for each material. Now he has 10 numbers of the conductivity level. So that's another problem encountered by the engineer. So because he has various number of conductivity level for the same material, so the problem is the variability of the conductivity level of the materials that he gonna use. And what is the source? What caused the variability? In this case, it can be the material supply by the suppliers. So the problem is originated from the suppliers. It may be because of the process of the supplier in order to produce those two types of materials, and the variability in the process cause the product, which is the two materials, to have variability in their conductivity level. So that can be from the manufacturing parameters of the supplier. It can be because of the temperature, the pressure, and anything else that will affect the process of producing the insulation materials. Or it can also be from the testing instruments used by the engineer when he measure the conductivity level of the two materials. Now, how we gonna handle variability? Now, in order to describe or to handle variability, we can plot them. We can calculate the average, we can calculate the maximum value, we can calculate the minimum value, we can calculate the range, and then we can calculate the standard deviation of the conductivity level. And the easiest way to do is to use the mean or the average of the conductivity level, and then use the average value, and to substitute the average value to the equation, and based on that we can get the thickness or of the wall that we need to use. This is an example of the plot of the conductivity level of the two materials, the rock wool and the foam. And we can see that from the plot and from the numbers, the mean or the average of the conductivity level is 140 for the rock wool, and the mean of the conductivity level of the foam is 110. And the unit is in joule meter per meter square Celsius hour. So that's an example of the problem encountered by an engineer. So sometimes when solving a problem, the engineer will face variability in the parameter of the model. So how the engineer handle or deal with variability? He can use statistics, right? So far we can say that with statistics we can handle variability. We can manage variability that we have in the real life. So what is statistics? So this is the formal definition of statistic. Statistic is the branch of mathematics dealing with the collection, presentation, analysis, and use of data to make decisions. And it is very clear, right, from our example. So we have variability in the conductivity level, and then we present the data of the conductivity level by using graph, by using number, by presenting the average of the conductivity level, by presenting the the maximum value, the minimum value, and the range of the conductivity level. And we use those data and or the information in order to make a decision. In our case, what is the decision? The decision is that the type of material that we need to use, and if we use that type of material, what is the thickness of the wall. So we can also say that we can use statistic to describe and understand variability. So the engineer in our problem, he just tests 10 materials. But how many materials that he has? He has so many materials. Maybe the supplier sent him 1,000 materials or 100,000 materials, but he just collect from that 1,000 materials only 10 of them, and he only tests 10 out of 1,000 or out of 100,000. And those 10 material, we call it a sample. It is a sample. And the original and the true or the original number of the materials, we call it as the population. So from the population, the engineer take a sample of 10, and he tests only the sample of 10. Why only 10? There are several reasons. He will need so much time and so much resources in order to test that 100,000 material. The only thing that he do, based on his limitation, based on the money that he has, based on the time that he has, he will just test 10 materials. And those 10 materials, we call it as the sample. So the sample size of the material, the sample size is 10. But the size of the population is so many. Can be 1,000, 100,000. So we take sample from the population, right? So if it is in the case of Indonesia, the population of Indonesia is 250,000. And maybe there is someone who are doing a research. He want to determine the average height of an Indonesian. So he may take sample randomly from the 250 million people in Indonesia. He may take 10 from West Sumatra, he may take 10 from Java, he may take 10 from Papua, and based on and from the sample, he measure the height of the Indonesian people, and based on the sample, he can say that the average height of an Indonesian is whatever. Okay, so that's a sample. And how we take sample from a population? We take it randomly, and that sample we call it as a random sample. So a population, it is clear that the population is all members of a defined group that we are studying. In the case of the engineer, in our example, it is it is all the rock wool, it is all the foam that he has in his factory. So that's the population. And in the case of Indonesia, it is the 250 million people that we have in Indonesia right now. That is the population. And the sample it is part of the population. It is a subset of the population. So if we model that by using a Venn diagram, so it is very clear that that the sample is the that the sample is the part of the population. It is a subset of a population. Uh, there are two branches of statistics. Branch number one is the descriptive statistics. The descriptive statistics deal with the numerical and graphical representation of data. I think I show you an example of the use of descriptive statistics when uh, I was showing you the average and the range and the minimum and the maximum value of the conductivity of the two material, and next to that number we have the graph or the dot plot of the conductivity level. That's we call it that we call it as the descriptive statistics. And the other branch of statistic, we call it as the statistical inference. So in the statistical inference, we deal with taking conclusion from a specific set of sample about the population. So in statistic inference, based on the sample, we try to make a conclusion about the population. Okay, I repeat, in statistical inference, we try to make a conclusion. We try to explain the population based on the sample. Okay, so it is from specific to general, from sample to population, from specific to general. That's statistical inference. But there are other type of reasoning. It is from general law to specific case. So the other type of reasoning, it is when we apply the law of physics to a specific case. So that's the type of reasoning from general law to specific case. So when we are using the equation of heat transfer to our specific case, which is deciding what material that we're gonna use for the wall insulation, that the reasoning from general law to specific case. But statistical inference, it is the opposite of that. We are going from specific to general, or or from sample to population. We try to to explain the population, or we try to make a conclusion for the population based on the sample. So this is an example of the descriptive statistic. We can use bar chart, we can use pie chart, histogram, dot plot in order to represent data. And also we can also use table. And together with the table and the graph, we can have the mean or the average, the minimum, the median, the maximum, and the range, the standard deviation of the data. So in descriptive statistics, we use numbers, and we use graph in order to describe the data. And from the number and from the graph, we try to take the information, what the data tells us. So that's the use of statistic descriptive. In statistical inference, it is very clear. From population, we take sample, and from this, we analyze the sample, we test the sample, and from the result of our test of the sample, we try to make an inference about population. We try to make a conclusion of the population. We try to explain the behavior of the population based on the sample. So this is a model explaining the two types of reasoning. The one that we have on the right, it is the statistical inference. We go from sample to population. So we test sample based on the result of our test. We try to explain the population, and the sample we take it from the population. And the thing that we have on the left, this is what we call it as the so we start from the general law, or by using the physical law, the law of physics, the law of chemistry, the law in biology, and based on that law, and we apply that law to a specific cases. And that case can be in when you are designing a product as an engineer. Okay, and I think that is it for this video, and thank you very much.